Hi, welcome back to another episode of Algebra in Words. We're continuing our discussion here on systems of linear equations. I went over an overview of that in a previous video, but in this video I'm going to specifically go over the addition-elimination method. I have 4 sets of systems of linear equations on the board. Before we get into solving them, I want to give a quick overview of the steps that we're going to use to do this method. Alright, then we're going to analyze the problems, and then we're going to ultimately do each problem one by one. So here's what the addition-elimination method is and what it means. In a case like this, what our midterm, our intermediate goal is to eliminate the terms that are alike, basically of the same variable. Once we do that, then we'll be able to solve for one of the variables, plug that value into one of the original equations to get the value of the other variable, and then we'll have both. Then we should check our answer by plugging both back into the originals, and we'll be done. Now, let's take a look at this problem here. And we're going to look at each group of problems and kind of compare and contrast. Now, here's what we're looking for. When we analyze these, alright, and before we even get into analyzing them, there's something we should also do, sort of 2 things, but it's one thing, which is we want to always make sure that our equations are in the same and consistent format. Okay, what does that mean? If you remember where I went over the types of linear equations in a previous video, what form are these equations in right now? They're in standard form, where all the terms with the variables are on the left equal to the constant or the number on the right. Okay? And when we do systems of linear equations, it's a good rule of thumb to, number 1, put all the equations into standard form. And that kind of sets up the second reason, which is once you have them in standard form, line up the terms with the same variables. Line up the like terms, as well as the constants on the right. That's going to help you solve the problem just a little bit easier. If the equations don't come in this format, that's okay. A lot of the equations will, but later some of them, just to challenge you, probably won't. So if they don't, rearrange them into standard form and then line up the like terms. That's the first thing. Once you do that, then let's analyze the problem, because that'll give us a little insight into what to do next and how to proceed. And believe it or not, we always want to look for the path of least resistance, the easiest way to do it. So here's what we're going to look for. Let's start with this one and compare the like terms. In these terms are x and negative x. And these terms are 3y and 2y. The constants really don't matter. They're just sort of byproducts, and they'll just be there and go along with whatever manipulations we choose to do. But here's what you want to ask yourself. When comparing the like terms, which variable or which set of like terms will be easiest to eliminate? And the answer to that is you want to say to yourself, you want to keep in mind, how do you eliminate like terms? By them being opposite of each other. So if we compare x and negative x, don't you agree that x minus x cancels out to 0? That's kind of our intermediate step in doing this problem. So since in this case the x and the negative x cancels to 0, we're going to focus on those to eliminate, and instead of doing it to the 3y and the 2y. We could do it to the 3y and 2y, but it would be a little more work. Why do that if we can just add these equations, combine like terms, and the x's eliminate, cancel out to 0? Okay? We'll do this problem in more detail in a second, but I want to look at each of the 4 groups. Okay, let's now analyze the second group. Now, let's look at the x terms only. We have x and 4x, and if we're looking at the y terms, we have 3y and, again, 3y. Alright? And what you want to ask yourself is, what could you do to one of the variable or one of the terms with the variables so that when you add it to the other like term, it cancels out to 0? If we compare the x and the 4x, we would have to multiply this x by -4, so that -4x plus 4x cancels to 0. But if we compare the y's, we could also say that since this is already 3y and this is already 3y, one of them would have to be negative. So for example, if we made this 3y negative by running or multiplying through a negative through this entire equation, then this would be -3y, this would be +3y, and when we add them together, they cancel out to 0. That's probably the way I would go for this one. Let's look at this next group. Okay, kind of similar to the last one in a way. They're all a little similar. But if we look at this one, we have 5x and x, and we have y and -3y. So again, ask yourself, to get rid of the x's, what would you have to do? Well, this one, if we made this one -5x, then 5x and -5x would cancel to 0. And to do that, we would multiply this equation through by -5. Or if we looked at the y's, we could say, since this is -3y, if we multiply this top equation through by 3, then we would have 3y minus 3y, and then the y's would cancel out to 0. Okay, both are equally easy to do. We kind of just have the choice of either one in that case. And finally, let's look at this fourth group. We have 3x plus 2y is equal to 1, 6x plus 5y is equal to 7. And again, let's just focus on the like terms one at a time. Let's focus on the x's. We have 3x and 6x, so don't you agree that if we multiplied the top through by -2, then this would become -6x plus 6x. This would eliminate to 0. Whereas if we compared the y terms, we would actually have to do a conversion of both of them. If we wanted to eliminate the y's, the terms with y, we might want to multiply the top equation through by -5, which would make -10y, and multiply the bottom equation through by 2, because then it would make this term 10y, and -10y plus 10y would then eliminate the terms with y. But I think it's easier if you only have to multiply one of the equations through by a factor, and in that case that would be probably multiplying the top equation through by -2. So I'm going to erase these problems except for this one, and then we're going to do each one. Okay, I chose these problems so they got a little progressively harder, and let's look at the first one. So in the first one, again, analyze the x's and analyze the y's. If you notice, the x and the -x, they're already opposite terms of each other, meaning opposite signs. So we don't need to do any manipulation to this. Let's just add these and combine like terms and see what eliminates. X minus x cancels to 0. You could write 0. I'll write the 0 for now, but otherwise you don't really have to write anything. And then, since we didn't do any changes, 3y plus 2y is 5y. And don't forget to combine the constants. -9 minus 11 is going to be -20. And now we're just going to do our simple algebra and solve for y. Divide both sides by coefficient 5. That cancels out the 5's, leaving 5 is equal to -4. And that's half the answer to the problem. What I usually tell my students to do for system of two linear equations is, remember, since the answer is a point, I like to put parentheses and whichever value we found to put it into the point. So we found y, let's put -4 in for y. And that reminds us to finish the problem and solve for x. Okay, so once you find the value of one variable, take what that is and substitute it into either one of the two original equations. It doesn't matter which. Try to choose the easiest if you think you could find it. But otherwise, just randomly choose. Let's just randomly choose the top. I'm going to take -4 and put it in for y. So we're going to have x plus 3. -4 goes in for y. Equals -9. And we're just going to simplify and solve for x. 3 times -4 is -12. Let's move the 12 to the other side by adding 12 to both sides. and we get x equals 3. Put that into the point, and that's the answer to that problem. And now I put the second problem on the board. Notice they're all both in standard form, and they're both lined up with the like terms lined up. Alright, so now let's analyze, let's try to figure out, is it going to be better to eliminate the x terms or the y terms? So let's figure that out. So we have x and 4x, then we have 3y and 3y again. Alright, now, one thing I want to point out real quick, a common mistake is, especially for people that are maybe just get confused, is you might remember that you have to add the equations to each other, but remember, you have to do it in such a way where one of the terms with the variables cancels to complete 0. A common mistake students make is you might forget about eliminating, but you might remember to add the equations. If we added these equations, what would we get? 5x plus 6y equals 3. That basically would just be a path that leads to nowhere. We would get another equation, but it would just do nothing functionally for us. We'd just sort of be stuck in limbo. Alright, so now, back to my question. If this was negative 4x plus 4x, that would eliminate to 0. But since we have 3y and 3y, what I'm going to do in this case is, it's not much of a bigger difference, but just for demonstration, I want to show we're just going to multiply the top equation through by negative or negative 1, and I'm going to write what that is converted right here. So negative 1 times x is negative x. Negative 1 times 3y is now going to be negative 3y. Negative 1 times negative 3 is now going to be positive 3. Okay, so the top equation multiplied through by negative 1 is now just rewritten here. And now we're going to add this equation with this equation, and we'll see if a term cancels out. I mean, we set it up to do it, so it should. 4x minus x is going to be 3x. 3y minus 3y, they cancel out to 0, so they're eliminated. Equals 6 plus 3 is 9. And now we'll solve for x by dividing both sides by coefficient 3. And we get x equals 3. That's part of the answer. Let's put that into the point. And now we want to find y. We're going to take 3 and we're going to substitute it into one of the original equations. Randomly choose, I'm going to randomly choose this equation. So in for x, we're going to put 3 plus 3y equals negative 3. Remember, this 3 went in here, which is that. There's a lot of 3's here. And we're going to subtract 3 from both sides to move all the numbers to the right. These cancel to 0. We have 3y equals negative 6. Divide both sides by coefficient 3. These cancel out, and we get y is equal to negative 2. Let's put that into the point. And our answer to this system of two linear equations is the point 3, negative 2. That's the point on the graph where the lines would cross and the point that they have in common. So again, I'm going to pause this and put up a third problem. I have the third problem up, and they're both in standard form, and we have this like terms lined up. So now let's start by looking at the x terms. We have 5x and x. And again, ask yourself, what would they need to be for these to cancel out? Well, if this is 5x and we made this negative 5x, then they would cancel out to 0. Or if we looked at the y terms, since this is negative 3y, what would we have to add to that to cancel it to 0? We would have to add positive 3y. And that would require multiplying the top equation through by just 3. So let's multiply. Honestly, we could have converted either the x's or the y's. When you're not sure, or when it could be either, just choose one. I'm choosing the y terms. So I'm going to multiply the top equation through by positive 3, and I'm going to write what that becomes in the line below. 3, so distribute. 3 times 5x is 15x. 3 times y is 3y, positive, and 3 times negative 1 is negative 3. And now, let's put our addition line and combine like terms starting on the left. X plus 15x is 16x. Negative 3y plus 3y cancels to 0. We can write 0, but let's just leave that empty. Equals negative 13 minus 3 is negative 16. Now, let's solve for x by dividing both sides by coefficient 16. These cancel to 1, leaving x is equal to negative 1. Negative 16 over 16 is negative 1. And let's put the negative 1 in for x into our point. Now we want to solve for y. We're going to take negative 1 and substitute it into either of the original equations. Again, try to use the easiest. There's not really a right or wrong answer. I'm going to choose this one this time. So in negative 1 in for x is going to be negative 1 plus minus 3y equals negative 13. Let's move the 1 to the other side by adding 1 to both sides. And we're going to get negative 3y is equal to negative 12. Divide both sides by coefficient negative 3. These cancel out, and we get y is equal to negative over negative is a positive 4. Put the 4 in for y in the point, circle that, and our answer to this system of two linear equations is negative 1, 4. So I'm going to erase this one, and we'll do our last problem for the video. I put our fourth problem up. In the beginning of this video, where I had the system over here, I told you that I was going to do that one, but I changed the problems a little bit because I wanted to demonstrate a specific thing. That's why I changed the equations. So we have this system, all right? And are the equations in standard form? Yes. Are the like terms lined up? Yes. So we can continue to the next step. Let's compare the x terms. We have 3x and 2x, all right? And again, you need to be thinking, what do you need to do to one term so that you cancel out the like terms? Well, in this case, we would need to multiply both of these by something for them to eliminate. For example, we would need to multiply the 3x times negative 2x, which would make negative 6x, as well as this 2x by 3, so that 3 times 2x is 6x, negative 6x plus 6x would then eliminate the x's. That's one way we could go. All right, now let's look at the y terms. And again, we kind of have a similar situation. There's not only one number that you can multiply one equation by that would make the terms opposite. For example, to make the y terms cancel out, we could maybe use the number 28. So we would multiply the top term, the top equation and the top term by 4, and the bottom equation by 7, because 4 times 7 would make positive 28, and 7 times negative 4 would make negative 28, and then these y terms would then cancel to 0. All right? Again, randomly choosing, I'm going to eliminate the x terms. So I'm going to multiply I'm going to multiply the equation on the top by negative 2. And I'm going to multiply the bottom equation through by 3. And now let's distribute and see what we get. In the top, I'm going to write that here. We're going to get negative 6x minus 14y equals negative 16. And then this equation, we'll write below it, 3 times 2 is 6x. 3 times negative 4y is negative 12y. And 3 times 14 equals 42. Now let's combine like terms. Draw the line and we'll add the equations. Negative 6x plus 6x, those terms now eliminate to 0, which was kind of the reason why we did what we did. Negative 14y plus 12y is going to give us negative 26y. And negative 16 plus 42 is 26. Divide both sides by coefficient negative 26. And we get y equals negative 1. Let's put that into the point. And now that we have y equals negative 1, take the negative 1, substitute it into y into one of the original equations. I'm going to randomly choose the top equation. 3x plus 7 times negative 1 equals 8. And let's continue simplifying so that we can solve for x. 7 times negative 1 is negative 7. Let me just put that here so that we know we're going to add 7 to both sides to move the negative 7 to the right. Plus 7, plus 7, and we get 3x is equal to 15. And now let's divide both sides by coefficient 3. To get x equals 5. And that's the answer to that problem. So there we go. We just looked at 4 examples using the addition-elimination method. To summarize the method, you take the 2 equations, make sure they're both in standard form, and line up the like terms. Then you want to analyze the x's and the y's individually. And you want to say to yourself, what do you need to multiply by or convert by so that when you add the like terms, one of the sets of terms, either the x terms or the y terms, you don't really want both. There could be situations for that, which I'll cover in a later video, but focus on one variable. What do you need to add to one of them to make them cancel out to 0? Once they cancel out to 0, then solve for one of the variables, whichever it is. Then once you get that answer, take that value, substitute that value in for whatever that variable was, into one of the original equations, randomly choose, plug it in, simplify, solve for the other variable, and put your answer in a point form because the solution to a system of 2 linear equations is a point with an x and a y. Okay? I also want to point out one last thing, which is that you can read more about systems of 2 linear equations as well as the addition-elimination method in my book, Algebra in Words. The link to the Amazon page is in the description box below, but for people that like to read along, you can start the linear equation sections. Linear equation starts on page 46. Solving a system of 2 linear equations starts on page 56 with an overview. And then I do each of the main 3 methods. On page 63 is the addition-elimination method, where I do some other examples that I didn't do in the video. So that's all for this video. Remember that in other videos we'll look at other example problems with other methods, as well as on Facebook and Instagram I'll go over another example or 2 using the addition-elimination method. I'm going to make sure to include at least one dealing with fractions. So anyway, thanks for watching, and I hope you found this video helpful. If you did, please give a thumbs up, please share with your friends, and please subscribe to the channel so you can be alerted when new videos come out. And I'll see you next time.